Okay. Acceleration of an object which is undergoing uniform circular motion is called centripetal acceleration. So yesterday we had discussed the definition of centripetal acceleration. Now, okay, let's write down the definition. Acceleration of an object undergoing uniform circular motion is called the centripetal acceleration. Now the expression for centripetal acceleration, let us consider a particle of mass m. Okay, the mass of the particle is m. It is moving with a constant speed. Let us say v, and its angular velocity is uniform. So angular velocity, say uniform is omega, say, and it is moving on a circular path, and the radius of the path is r. Okay, and the center suppose is O. Then at any time
Okay. So a circle represents this circular path on which the object is moving. O is the center. Let us say at any time the particle is at point P on the circular path. Then let us set time equal to t. The position vector of the particle is given by r1. Let us say at at time t plus delta t, the particle is at q. So it is at point q here. The position of the particle, position vector of the particle at time t plus delta t is, let us say, r2. Okay, so r1, r2 are the position vectors of the particle. So we can say that OP vector represents the position vector r1, OQ vector is r2. And also because it is a circular path, so r1 magnitude is equal to r2 magnitude is same, is equal to radius of the circular path. And now let us say the particle has moved through a angular displacement of delta theta. So angular displacement, small angular displacement is equal to delta theta in how much time? In time, the time is t plus delta t to t. So in time interval of delta t. So therefore the angular velocity will be given by delta theta divided by delta t, because it is the rate of change of angular displacement. Okay, now let us say we know the linear velocity at any point on the circular path of an object moving on with a uniform speed is given by the tangent to that path at that point. So let us say v1 is the velocity, instantaneous velocity of the particle at point p at time t, and the velocity is v2 at point q2 at time t plus delta t. So let us call this A and let us call this B. So P A vector represents velocity v1 and PB vector represents velocity v2 at q. Now because speed is uniform, the magnitude of these velocities v1 is equal to v2 is equal to say v, that is the speed, uniform speed of the particle which is moving on the circular path. So if you want to represent with the vector sign, you can get the magnitude of it. Now, because acceleration is what? Rate of change of acceleration is rate of change of velocity. So how the velocity is changing? Let us find out the change in velocity, and the time interval is already known, that is delta t. So finding out the change in velocity will give us the acceleration acting on the particle. To find out that change, let us consider a point P dash outside corresponding to point P and draw a vector PA equal and parallel to PA. So vector P dash A dash equal and parallel to vector PA, which will represent velocity vector V1. And same way, draw another vector from P dash equal and parallel to QB, representing the velocity V2, and call this PB dash. So this is velocity V1, this is velocity V2. Finding out the difference, let us join A and B. So vector AB. Now from this, so this angle, because this angle between the two position vectors is delta theta, and angle between the vectors perpendicular to both will also be delta theta. So from triangle, vector triangle P dash A dash B dash, we can say that P dash B dash is equal to P dash B dash vector is equal to PA P dash A dash vector plus A dash B dash vector, because these two vectors P dash A dash and A dash B dash are in same sense, and this is the resultant of the two in the opposite sense. So P dash A dash vector plus A dash B dash vector is equal to P dash B dash vector. So from this we can get A dash B dash vector. So A dash B dash vector will be equal to P dash B dash vector minus P dash A dash vector, and P dash B dash vector is V2 vector minus V1 vector, and let us call this the delta V vector, which is a change, which is giving us the change in two vectors V2 and V1, and this is giving us the change in velocity. So delta V vector represents the change in velocity V2 and between V2 and V1. Now suppose delta theta is very small, then we can consider the AB as an arc of a circle of radius P1 A dash P dash A dash. So A dash B dash is an arc of a circle of radius P dash A dash. Because this angle is small, because the delta theta is small, we can consider that A dash B dash arc is equal to length a dash b dash. So because this is small, so we can consider this arc equal to this line a dash b dash. Now we know delta theta, because it is the angle made at the center p dash, is equal to arc divided by radius, and arc is equal to a dash b dash and radius is equal to p dash a dash. So from this, let us consider this is a circle of radius p dash a dash, and this is the arc a dash b dash. So length of the arc divided by the radius gives you the angle. So a dash b dash upon p dash a dash is equal to delta theta. So let us put these values from here. So delta theta will be equal to a dash b dash is delta v and its magnitude, and a dash b dash p dash b dash is that v1 vector and its magnitude, and this v1 is same as equal to v. So this is same as delta v upon v, because v1 is equal to v2 is equal to v. Now what is delta theta from previous result? Here it is. From this we get delta theta is equal to omega delta t. So use it here. This implies omega delta t is equal to delta v magnitude vector, and just we can write down v, because magnitude of vector v is equal to v, or just for our convenience let us use mod. Now just rearrange. So on rearrangement, delta v divided by delta t. So this divided by t is equal to omega v, like this. And what is v? This is equal to omega r. So omega into omega r. We already know v is equal to omega r, or omega is equal to v upon r. So is equal to omega square r, or we can also get will be equal to, instead of uh, use it v only and make it v by r. So v by r into v square upon r. So omega is equal to v upon r. So this also we can use. So we are getting two expressions on the right hand side, which is the same thing. Now what is this? This is change in velocity per unit time. So it is acceleration. So which is a centripetal acceleration. So we get an expression for centripetal acceleration equal to v square upon r, or equal to omega square r. So that is the expression for centripetal acceleration. And its magnitude. You can represent it with the help of a vector and its magnitude also. So AC is equal to omega square r is equal to v square upon r. Okay, once again finding out the direction of acceleration vector, because it is incomplete without direction. So direction of acceleration vector is same as the direction in which the velocity is changing. To find out what is the relation between, what is the angle between change in velocity vector and the velocity vector, look at this triangle P dash, A dash, B dash, and delta theta is the angle A dash, P dash, B dash. Now, as delta t approaches 0, delta theta also approaches 0. The point B dash comes close to A dash. So as it comes close to A dash, very close to A dash, the vector A dash B dash becomes perpendicular to vector P dash A dash. That means change in velocity vector becomes perpendicular to the velocity vector at point P dash. So we can find it here. So this is the velocity vector V1, and the change in velocity vector is perpendicular to this velocity vector, and making so therefore this change in velocity vector direction is along the radius vector and towards the center, and therefore acceleration vector also has the direction of along the radius vector and towards the center. So centripetal acceleration always acts along the radius towards the center of the circular path. Now let us consider a particle which is moving on a circular path of radius r with center O. And radius is r. And let us say the linear speed of the particle is changing with time. That is, the distances traveled by the particle in unit time keep on changing. So linear speed along the circular path is changing with time. And let us say at any instant the speed is v. At any instant, speed of the particle on the circular path is v, and omega is the angular velocity. And angular velocity at that instant is omega, and angular acceleration is, say, alpha, because we represent angular acceleration by letter alpha. Now centripetal acceleration, which is, say, represented by AC, is equal to v square upon r. We have already derived this expression, and this is also equal to v omega. Okay, so this velocity, this acceleration acts along the radius towards the center of the circular path. So this is the direction in which the acceleration acts along the radius towards the center. Now tangential acceleration. So tangential acceleration represented by AT. So we have already got an expression for tangential acceleration is equal to r alpha. We remember relation between acceleration, linear acceleration, and tangential acceleration is equal to r into angular acceleration alpha. And the tangential acceleration always acts along the tangent to the circular path at any point where the particle is located. So this is the direction of angular acceleration if the particle is at point P. And this acts in the plane in which the particle is moving on a circular path. So this is the direction of tangential acceleration. Now if the particle is at point, say, Q here, tangential acceleration will be like this. So at Q. Similarly, at different positions, the particle tangential acceleration will be always along the tangent to the path at that point. Now AC and AT, these acceleration are perpendicular to each other at every point. So wherever it is, the acceleration, in this case x again will be like this. So AC is the acceleration, centripetal acceleration. So always AC and AT are perpendicular to each other. So therefore the resultant acceleration A is vector is equal to AC vector plus AT vector. That is the vector sum of the two. And we know how can we get the vector sum of the two by using parallelogram law. To A vector, its magnitude is given by AC vector plus AC square, or just write down AC vector its magnitude and square plus AT vector its magnitude and under root. Okay, or you can just write down A vector magnitude is equal to AC square plus AT square is equal to, put the value of AC here. So AC is equal to V omega whole square plus AT is alpha R alpha square under root. So this is how we can find out the net acceleration acting on the particle moving on a circular path. Now let us discuss two cases. If acceleration along the tangent, that is tangential acceleration of the particle, is zero, that means the particle is moving on a circular path with uniform speed. So when it is uniform, the speed is uniform, acceleration will be zero. So AT will be zero when it is moving with a uniform speed. Then the acceleration will be only equal to the centripetal acceleration. So acceleration will be equal to AC is equal to V square upon R or V omega or omega square R. So all three expressions are for the centripetal acceleration. Now case 2, when if AC is equal to 0, that is centripetal acceleration is equal to 0. That means only tangential acceleration is acting on the particle. So when the tangential acceleration is acting on the particle, that means the particle is moving on a straight line, along a straight line, not along the circular path. Because whenever the particle moves along a circular path, there is always a centripetal acceleration. So AT will be equal to, will have some value, some finite value. Okay. The acceleration acting will now be only tangential acceleration, and the particle will accelerate along the tangent to the circular path given by alpha r. Okay, so these are about tangential acceleration and centripetal acceleration. And the question is, a boy stands at 78.4 meter from a building. And throws a ball which just enters a window 39.2 meter above the ground. Calculate the velocity of projection calculate the velocity of projection of the ball. Okay, so let us solve it. Let us suppose this is a building. And this is the ground level. Okay, and so this height of the window is 39.2 meter. Okay, and suppose this is the position from where he throws the ball. So distance of this position from the building is 78.4 meter. Boy stands at 78.4 meter from the building, and he throws a ball which just crosses, enters the building, and this will be moving in along this path. So when he throws the ball like this, so it is moving along this path. So this is the initial velocity with which he is throwing the ball. So let us suppose the u is the velocity and it is being projected at an angle of theta. So we have to find out u and theta. Okay, because initial velocity we want to find out the magnitude as well as direction in which the particle is, or the ball is projected initially. Now we can use the expression of maximum height. If you remember, the expression for maximum height was u square sine square theta divided by 2g. So this is same as angle theta with the horizontal. So we are using this expression u square sine square theta upon 2g. So this is the expression for maximum height and horizontal range. Horizontal range, as we know, so this is the distance from the building from which he throws the ball. And we know this is symmetrical, the path is symmetrical on both sides. So this distance where it lands on the ground from the building is also same. So this total is distance is horizontal range from the point of projection to the point where it touches the ground. So horizontal range is given by expression u square sine 2 theta divided by g. So we got these two expressions and we know the value of this. It is 2 into 78.4 and we